All right, hello there. In this lesson, we are going to talk about how we can write and solve rational equations to solve what we're calling changing ratio problems. Problems where we have a particular ratio of items and we're looking at changing that ratio to meet a new condition. So the concept here is, let's say that Carol made 24 sugar cookies and 18 chocolate chip cookies. But she wants 60% of her cookies to be chocolate chip. So we need to know, well, how many more chocolate chip cookies would she have to make? We need to understand that in order to answer this question, we have to know that if Carol makes more chocolate chip cookies, she's also going to be making or have a larger total number of cookies. So in this example here, it says if we let C equal the additional chocolate chip cookies that Carol will need to make, then we're looking at the ratio of her chocolate chip cookies to her total number of cookies. And the chocolate chip cookies, well, she's got 18 right now. She's going to make C more, so that's 18 plus C for chocolate chip cookies. And if she also made 24 sugar cookies, right now she has 42 cookies total. And with these additional chocolate chip cookies, she's adding C cookies to that also. So we get a ratio of 18 plus C over 42 plus C. Now we know that that ratio of chocolate chip cookies to total cookies, the goal is to have it equal a ratio of 60%, which would represent 60% of the cookies being chocolate chip. So we set that ratio equal to 60% as a decimal, 0.60 here. And then we can solve that equation for C, which would then be the additional chocolate chip cookies she needs to make. So let's take a look at this problem here. So in this problem, there are 120 men and 160 women registered to attend a conference. Assuming that no more women register for the conference, so it's a fixed number of women at 160, how many more men need to register to make the percentage of men who are attending the conference 55%. So we have to understand here that we're looking for the ratio of men, which would be to the total number of people registered for the conference, to be 55%. So what we need is that for the men, to the total number of people, at the conference to equal that 55%. Well, right now, the number of men at 120 and the total people, so this is your 120, the total people would be the men plus the women. So 120 plus 160 or 280 people. That ratio is not at 55% right now. And so we need to use a variable, and we can decide what letter we want to use for that to represent the extra men or the additional men that we would need to register for the conference to make that percentage at 55%. So let's let M equal the additional men. So again, we have to understand that we're going to add more men to the group of men. So we have the 120 plus the additional men, M. And our 280 total people is also going to increase by this M additional men. So the denominator becomes 280 plus M. And we want that to be our 55%, but in order to solve it as an equation, we need to write that 55% as a decimal, so 0.55. So now we have a little rational equation, and looking at that, we need the LCD would be the only denominator we have that isn't 1, which is our 280 plus M. So now if I solve this, my LCD is that 280 plus M. So multiplying each of these, so we have the 120 plus M over the 280 plus M times the LCD over 1, of course, for its denominator. and that would equal the 55% as a decimal. Which also has a denominator of 1, times the LCD. So back over here on the left in our product, the factors of 280 plus m will reduce to 1. So that's going to give us 120 plus m. And over here on the right, our denominators are both 1, so there's nothing going to reduce. So we have our 0.55 to distribute to the 280 plus m. All right, so this is going to give us 120 plus m equals, distributing the 0.55, will give us 154 plus 0.55 m. So we have a little simple linear equation here. And I would subtract 0.55 m from both sides. And I would also subtract the 120 from both sides. And so this is going to give me 0.45 times m equals 34. And dividing both sides by 0.45 gives an m value that is equal to 75.555 and so on and so forth. One of the things that you need to understand here, again, it's important to remember what m represents, is additional men. And so when you're talking about that particular type of a context, decimals don't make any sense. And so you would here round up to 76. So what you're looking at here is, it's not about, but it is 76 in this case, because we're talking about the quantity of men. The other thing is, even if this had been 75.1 or 75.2, we would still need to round up, because if we don't, if we round down according to the normal rounding rules, we actually don't quite then have enough men to reach our original parameter of 55%. So you always want to round up in a situation where you need a whole number quantity. And then we can write our conclusion. So we're looking here then at, and so we have to figure out, remember, if we're going to start our sentence with a number, we'd have to spell it out. So we can spell out 76 if we want to, or we can reword it so we don't need to do that. So I'm going to say 76 more men need to register for the conference. To make the percentage of men %. If you would like to try this practice problem, pause the video now. Alright, so looking at this second example. So in the second example, it says a save percentage in lacrosse is found by dividing the number of saves by the number of shots faced. So anything that compares two numbers through division is a ratio by definition. So that is basically describing a particular ratio called the save percentage in lacrosse and how we calculate that. So that save percentage is equal to the number of saves divided by the number of shots faced. So in this case, it says that a lacrosse goalie saved 9 of 12 shots. So that's an initial ratio, 9 of 12. So saved 9, 12. So that would be 9 to 12. The question here we're looking at answering then is so how many additional consecutive saves? So we can't miss any. That's a more different type of problem, a little more complex as far as how we'd solve that. So how many additional consecutive saves in a row must the goalie make to raise his save percentage to this value right here? So notice the save percentage is actually already written as a decimal, so we don't have to do the conversion this time, but it's the same concept. So we're looking at choosing a variable to represent those additional consecutive saves. So I'm going to and I'm just going to use x. I'm not a fan of s as a variable, so I'm going to let x equal the additional consecutive saves. So we would take the number of saves that he has right now plus the additional ones, so that'd be 9 plus x. And then the total shots that he has faced so far is 12 plus an additional x shots for the extra saves. And we want that new ratio right there to be equal to the decimal 0.850, which is basically 85% in a percentage form. So then we solve this. So our LCD is the 12 plus x. So multiplying both sides, or basically each term, by the 12 plus x, we are going to get the equation 9 plus x equals the 0.850 times the 12 plus x. So we now have the 9 plus x equals 10.2 plus our 0.850, or just 85 would be okay too, x. And subtracting the 0.85x gives us 0.15x equals, subtracting the 9 gives us a 1.2. And then dividing both sides by the 0.15, we get an x value of 8. So no need to round up in this case. We get a nice exact value. So that's telling us that we need 8, or this goalie needs 8 additional saves. So the goalie needs 8 additional consecutive saves. The word consecutive is important for the context here. To raise his save percentage. To 0.850. If you'd like to try this practice problem, go ahead and pause the video now. And that concludes this lesson.